Welcome and thank you for joining. Let's take a look at another trig equation, and this time we have 3 sine x plus 3 cosine 2x equals 2. As you can see here, we have two different ratios involved in the equation, the sine and cosine, and we prefer to have a single one. And the angles inside each ratio are x and 2x, so they're different angles, so we need to take care of that as well. Whenever you see a double angle term, the first thing you have to think of is replacing that term, and for cosine 2x, we have 3 different formulas we can choose from. So we have cosine 2 theta equals cos squared theta minus sine squared theta. And if we replaced the cos 2x by cos squared minus sine squared, this will resolve the problem of having a single angle, so it will be x everywhere. But we still haven't resolved the problem of having different ratios, so this won't be a good choice in our case. If we decide to go for the second formula for the double angle cosine, now this will resolve the problem of having a single x, so cosine 2x would be 2 cos squared x minus 1, but we would still have cosine and sine in the same equation, which we prefer not to have. So let's take a look at our last option, which is 1 minus 2 sine squared theta. So if we bring 1 minus 2 sine squared theta here for cos 2x, then we will have only sine throughout the equation and the angle would be single. So let's do just that. We have then 3 sine x plus 3 1 minus 2 sine squared x equals 2. Expand and simplify. 3 sine x and then plus, remember that this number 3 here will have to multiply every term inside the brackets. So we have plus 3 minus 6 sine squared x. And since we know that we end up with a quadratic equation or a polynomial equation, we're going to bring the number 2 to the left side. So minus 2 equals 0. Let's simplify one more time. So from highest to lowest degree, then we have negative 6 sine squared x. So the next term would be the first degree term, which is 3 sine x. And then plus 3 minus 2 equals 1. So plus 1 equals 0. So quadratic equation, leading coefficient is negative. I prefer to have the positive leading coefficient. It's not a must-do step, but it can be useful. So minus 3 sine x and then minus 1. You simply either multiply or divide by negative 1 every term in the equation. Now, my first attempt would be to solve by factoring. And for this, I need to think if there are two numbers that can multiply to negative 6 and add to negative 3. There is limited set of factors or set of numbers that can do that, that can give a product of negative 6. And none of them will give a sum of negative 3. So I will give up the idea of factoring and solve this by using the quadratic formula. So the unknown variable here is sine of x. And I will color code it to make it easier for us to see the variable. So we have 6 sine of x to the power of 2. And then minus 3 sine of x. And then minus 1. As you can see, the variable in our case would be sine of x. And the coefficients here would be coefficient A is 6, B is negative 3, and C is negative 1. We're about to use the quadratic formula. That's why it's important to identify the coefficients in front of each variable. Remember, this is our variable here. So we're going to say that the variable sine of x equals, and start off by substituting a, b, and c into the quadratic formula. Remember that the quadratic formula is negative b plus minus square root b squared minus 4ac over 2a. It's one of the formulas we must memorize, and as we have mentioned in class, We can't memorize all the formulas out there. It's important to make connections between them, but there are some we can't do without, and quadratic formula is one of them. So sine of x would be equal to negative b, that means negative 3. I'm showing all the steps here, but obviously you can cut the steps shorter. Plus or minus the square root of b squared, which makes negative 3 squared, minus 4 times a, which is 6, times c, which is negative 1, divided by 2 times a, which is 2 times 6. So here we have sine of x equal to positive 3 plus or minus. You just evaluate this expression in the calculator or in your head. So this would be a positive 9. This would be a positive 24, which makes the expression inside the root 33 over 12. Now this would be the sine of x. We are ready now to determine the value of sine of x. And you can see that here we have two solutions, the plus and the minus solution, right? So sine x equals 3 plus root 33 over 12, or sine x equals 3 minus root 33 over 12. So what we are going to do in this case is round the answer to 4 decimal places, since this represents the sine ratio of some angle x. So that will give 3 plus the square root of 33 divided by 12. Oops. 0.7287. And 3 minus root 33 would be square root of 33 divided by 12 equals negative 0.2287. So these are the ratios we're working with, and we're ready now to solve for the unknown angle. So here we go again. We're going to say that angle x will be equal to inverse sine 0.7287. Obviously, we are going to get rounded answers. So set your calculator to radian mode so you can get the answer in radians. So inverse sine 0.7287 will give the angle 0.82 radians. Here we go. And using the other equation, we're going to have x equal inverse sine negative 0.2287. So x equals, so inverse sine negative 0.2287. That will give negative 0.23 radians. So next we have to draw the angles on the Cartesian plane so that we can figure out the other angles within 0 and 2 pi that have the indicated sine ratios. So you can do this algebraically, obviously, but it is best that we draw the angles because it gives a clearer explanation of the answer. So 0.82 radians is like almost a radian. A radian is about 60. So it seems that we're about here. And since we use the sine ratio, then the other angle will be on the other side of the sine axis. So here goes the first angle of 0.82 radians. And here is the second angle, which would be pi minus 0.82. So and that equals, rounded to nearest two decimal places, 2.32. Similarly, we're going to work with the next angle. So the angle that the calculator gave us is negative, and that's because it's probably the smallest angle the calculator can read from the x-axis. So we'll draw the angle the calculator gave us. And this would be negative 0.23, and using the sine ratio we know that the other angle will be found by reflecting the terminal arm about the y-axis. So here goes our first angle. Always read positive because our domain is positive in this case, and here go both angles. So as you can see here, we're going to have, for the green angle, we have pi plus 0.23. And for the pink angle, we have 2 pi, take away 0.23. So remember, this is 0.23 radians, this related acute angle. So the pink angle would be the entire 2 pi less the related acute, whereas the green angle would be pi radians plus the related acute angle. So let's evaluate this, and we'll have the angles x and y equal to, use the calculator to find pi plus 0.23, and you get 3.37 radians. And 2 pi minus 0.23, which will give 6.05 radians. And here go all the solutions. So let's box them up. 0.82, and then we have 2.32, and next angle is 6.05 and 3.37. So if you look at the graphical representation or solution, this is what you see. So this would be the left side of the equation, the graph of the left side of the equation from 0 to 2 pi. Let's highlight this. So we start here, continue on. So this would be the graph of 2 sine x plus 2 cos 2x, so all the way to pi. And this would be the line y equals 2, and as you can see, they intersect at the indicated points, which were the solutions we found. So I hope this made sense, and happy studying. Bye for now.